Once, long before deserts ruled North Africa, a river wider than memory carved its way through green worlds. It shimmered beneath a sky thick with steam, its banks alive with giants. But from those waters rose a shadow unlike any that had ever walked the earth. We would not meet that shadow again for nearly 100 million years. Not until a man with a hammer struck stone in the Egyptian desert and heard the echo of something impossible. This is the story of the creature that should not have existed. For more than a century, the name Spinosaurus has drifted between fact and legend. A predator said to rival Tyrannosaurus rex, yet built for a world neither wholly land nor water. Some called it a fraud, others a monster. All were wrong. Tonight, we follow its trail, from the lost bones of a vanished expedition to the revelations that rewrote dinosaur science. Stay with me till the end, because the truth hidden beneath these sands changes what we thought we knew about every predator that ever lived. The desert gives nothing easily. Temperatures climb past 50 degrees, wind scours the dunes like a living flame. But beneath that heat lies an older landscape, a fossilized delta stretching from Morocco to Egypt, the Kem beds, the graveyard of the river hunter. In 1912, a German paleontologist named Ernst Stromer trekked across this wasteland with a handful of guides and a vision that bordered on madness. He was searching for bones in a place that seemed intent on erasing them. Days became weeks, sandstorms buried his camps. Yet in one sun-bleached cliff, he saw the glint of fossilized marrow, a vertebra huge and hollow, shaped for buoyancy. What Stromer uncovered defied every pattern known to science. Bones as light as a bird's, claws curved like a fisherman's hook, and teeth not serrated for tearing flesh, but smooth for gripping prey. Each vertebra, delicate yet strong, hinted at a creature built for life in water as much as on land. It was unmistakably a hunter, but of what? He named it Spinosaurus aegyptiacus, the spined lizard of Egypt. Its sail, formed from elongated neural spines, rose like the masts of a sunken ship. Its skull stretched longer than a man is tall, and its nostrils set far back, suggesting a lifestyle that challenged everything known about theropod dinosaurs. Stromer suggested it hunted fish in the rivers, its jaws snapping with precision rather than brute force. Yet few believed him. Dinosaurs, the world thought, were creatures of land. They did not swim. War, however, would make believers of none. When World War II reached Munich, the museum housing Stromer's fossils was destroyed in an air raid. The only known Spinosaurus skeleton vanished, leaving behind drawings, field notes, and photographs, shadows of a truth the world had yet to see. For decades, the river hunter existed only in memory, sketches, and speculation. But rivers, like science, do not remain silent forever. Half a century later, the sands of Morocco began to whisper its name again. Local collectors uncovered partial skeletons in the Kem beds, vertebra, teeth, and fragments of the iconic sail. In 2014, paleontologist Nizar Ibrahim led a team to excavate the most complete Spinosaurus specimen found to date. With each carefully extracted bone, the river hunter returned, not as myth, but as a living creature reconstructed in astonishing detail. Its anatomy defied expectations. The pelvis and hind limbs suggested reduced terrestrial capability, while its elongated neural spines supported a massive sail that may have regulated temperature or played a role in display. The long, narrow skull, filled with conical teeth, indicated a diet of fish, while its robust forearms, tipped with formidable claws, hinted at hunting versatility. Spinosaurus had become the only known semi-aquatic dinosaur, a predator that challenged our understanding of how theropod dinosaurs could live and hunt. Yet the scientific community did not receive this revelation quietly. Debates raged. Was it truly bipedal or quadrupedal? Could it swim like a crocodile or merely wade? Its size estimates varied wildly, some suggesting it was longer than T-Rex, others claiming it was smaller than previously imagined. Every new study reshaped what we thought we knew about every predator that ever lived. To look at Spinosaurus now is to look at a paradox, a creature designed for both land and water, a predator that ruled rivers while others dominated plains, a hunter whose existence rewrote evolutionary rules. And yet, for all we know, much remains hidden. Its skeleton still lacks pieces, its life habits are inferred from anatomy and environment, and its behavior, the way it moved, hunted, and interacted, remains largely a mystery. Imagine the waters of North Africa 100 million years ago. Giant fish, coelacanths, and sawfish glide through currents as Spinosaurus lurks beneath, barely visible, sails cutting through foggy sunlight. Its teeth close with precision. Claws snatch prey from the river. On land, smaller theropods watch cautiously. Even Tyrannosaurus rex would have hesitated in these waters. The river hunter dominated an ecosystem no other predator could claim, a predator adapted to a world no paleontologist could have imagined. And yet the story is not only of bones and rivers, it is of obsession, loss, and perseverance. Stromer's painstaking documentation, preserved against war and time, laid the foundation for modern discovery. Local Moroccan collectors, scientists driven by curiosity, and advanced imaging technologies all contributed to reconstructing a creature thought lost forever. It is a testament to the persistence of human inquiry that the past will reveal itself if we are patient enough to listen. Spinosaurus' tale also reminds us why studying these giants matters. Understanding this predator informs not only the mechanics of prehistoric ecosystems, but the very processes of evolution. It challenges assumptions about terrestrial dominance, ecological niches, and the ways vertebrates adapt to multiple environments. Every claw, vertebra, and tooth recovered is a page in a book that millions of years of sediment have written, waiting for us to read. Yet even as we reconstruct the river hunter, questions remain. What exact behaviors did it exhibit? How did it hunt with such specialization? Did the sail serve a function beyond display or thermoregulation? These mysteries linger, and the answers are buried in rock, in fossils, in the patient work of scientists who dare to interpret the silent testimony of the past. The sands of North Africa still hold many secrets, and each fossil is a reminder that our understanding of life is provisional. Spinosaurus, once a shadow in Stromer's drawings, now emerges as a vivid example of nature's creativity, a creature that defies expectation and invites us to rethink what we know about predators.
The river hunter waits, not in the waters of the past, but in the questions it leaves behind. Questions that only by following its trail to the end can we begin to answer. And as we trace its journey from fossilized fragments to modern reconstructions, we see a truth that resonates far beyond paleontology. That discovery is as much about unlearning as learning, about questioning what we take for granted, and about remaining open to the extraordinary. Tonight, we begin that journey. From the lost fossils of a vanished expedition to the revelations that will challenge everything you thought you knew about predators, the river hunter beckons. Stay with me, because the secrets it holds will transform our understanding of an entire era. Once buried in sketches and shattered bones, Spinosaurus now rises from the sands with clarity that Stromer could only dream of. In Morocco, paleontologist Nizar Ibrahim and his team meticulously unearthed vertebrae, skull fragments, forelimbs, and the long, mysterious sail. Each fossil was a piece of a puzzle, yet when assembled, they revealed a predator unlike any the world had ever seen. Its skull stretches over 1 meter in length, narrow and elongated, designed not for tearing the thick hides of dinosaurs, but for gripping slippery prey. The teeth, conical and smooth, hint at a diet dominated by fish, yet capable of capturing small terrestrial animals. Every detail, from the nasal placement far back on the skull to the structure of the palate, suggests a predator built for ambush in shallow rivers. The forelimbs are equally remarkable, massive, muscular, tipped with hooked claws. they indicate power and versatility. Unlike most theropods, which relied on hind legs and jaws, Spinosaurus could grasp, hold, and manipulate its prey with a dexterity previously unseen in giant dinosaurs. Its hind limbs, in contrast, are shorter than expected, and the proportions suggest it could not run as efficiently on land as other predators of its size. The river hunter was a specialist, adapted to an environment that was part river, part floodplain. The sail on its back, formed from elongated neural spines extending up to 2 meters, remains a mystery. Some scientists propose thermoregulation. The sail acted as a giant solar panel, warming the creature in cool mornings or dissipating heat in the midday sun. Others suggest display, a warning to rivals, a signal to potential mates. Whatever its function, the sail dominates the silhouette of Spinosaurus, marking it unmistakably in life and in legend. Perhaps the most astonishing feature is its tail. Unlike any other theropod, the Spinosaurus tail is long, flexible, and flattened laterally, resembling that of a giant crocodile. Modern biomechanical studies suggest it functioned as a paddle, propelling the predator through the water with remarkable efficiency. In this adaptation, we see evolution bending the rules. A dinosaur that swam as effectively as it walked, a creature that blurred the line between terrestrial and aquatic life. Imagine a river teeming with giant fish, coelacanths, sawfish, and lungfish gliding through the current. Beneath the surface, the river hunter waits. Its long jaws cut through the water silently, eyes trained on the shadows beneath the ripples. A quick strike, and a prey item disappears into its mouth. This is not the brute force hunting of T-Rex, nor the terrestrial dominance of Carcharodontosaurus. This is calculated aquatic predation, honed over millions of years. Spinosaurus's anatomy challenges our understanding of theropod evolution. Where we expected land-based predators, we find a semi-aquatic specialist. Its skeleton tells a story of rivers and deltas, of evolutionary innovation, and of ecological niches that were far more complex than previously imagined. Yet the story is not only in the bones. Sediment analysis reveals the environments these creatures inhabited: river channels, shallow lakes, and seasonal floodplains. Fossilized fish scales embedded near vertebrae suggest diet, while the sedimentology of the Kim beds reveals rivers that were dynamic, unpredictable, and teeming with life. Spinosaurus was not merely surviving, it was thriving in a habitat that few predators could dominate. Even within its own ecosystem, competition was fierce. Other giant theropods prowled the plains: Carcharodontosaurus, Deltadromeus, and Rugops. Yet Spinosaurus carved a niche apart, hunting in waters where others could not follow. Its adaptations from skull to tail demonstrate nature's capacity for specialization and the evolutionary creativity that allows life to fill every ecological opportunity. The more we uncover, the more Spinosaurus confounds expectation. Its skeleton, reconstructed from fossils spanning Morocco and Egypt, tells a story of innovation and specialization unseen in any other giant predator. While most theropods relied on brute strength and speed on land, Spinosaurus was designed for stealth and dominance within water. Its nostrils, positioned far back on the skull, allowed it to breathe while most of its head remained submerged. Its eyes, set high on the skull, scanned the surface for movement. Each adaptation hints at a life spent hunting in rivers, stalking prey unseen until the very moment of attack. Modern biomechanical models, run on computers and tested in simulated water tanks, suggest that Spinosaurus could propel itself through the current using its massive tail like a paddle. Unlike the stiff tails of other large theropods, this tail's flexibility allowed it to maneuver with agility and speed, hunting fish and smaller aquatic reptiles with precision. For decades, paleontologists doubted that such a creature could exist. A predator of this size, specialized for semi-aquatic life, seemed impossible. Yet here it was, reconstructed bone by bone, defying the rules established by millions of years of terrestrial predators. The forelimbs with enormous claws provide further insight. Some scientists hypothesize they could snatch prey from the water, hook fish against the banks, or even assist in occasional forays onto land. The claws, curved and razor-sharp, were a versatile tool, revealing a hunting strategy that relied not on speed alone, but on adaptability and cunning. Spinosaurus was a predator of rivers, yet it was not helpless on land. It simply moved differently, walking with a gait unlike any other theropod of its size.
Even the iconic sail of Spinosaurus continues to intrigue scientists. Its function remains debated. Some propose it was a thermal regulator, warming or cooling blood as needed. Others suggest it was used in mating displays, intimidation, or signaling. The sail, however, is more than just a mystery. It represents evolutionary innovation, a structure that required energy to grow and maintain, yet provided survival benefits in a specialized environment. Its presence reinforces the notion that Spinosaurus was no ordinary predator. It was an experiment in adaptation on a scale never before imagined. Fossilized stomach contents offer tantalizing glimpses into the diet of this river hunter. Remnants of large fish, lungfish, and even small crocodiliforms suggest that Spinosaurus was an apex predator of rivers, capable of striking with surgical precision. Its hunting strategy may have resembled that of modern crocodilians, lying in wait beneath the water's surface, striking with explosive speed. Yet it was larger, longer, and more specialized than any modern analog, a predator that could dominate rivers where others could not. The debates in paleontology reflect the significance of these discoveries. Some researchers question the completeness of the Moroccan specimens. Others reanalyze the proportions of the limbs and vertebrae, arguing over swimming capability and posture. Some proposed quadrupedal locomotion on land, others bipedal. Each argument, each paper, each new fossil fragment reshaped our understanding of this extraordinary predator. Science, in this sense, mirrors the rivers Spinosaurus once ruled, dynamic, flowing, and never truly settled. To witness Spinosaurus in life, one must imagine a complex ecosystem of rivers, floodplains, and forested banks. Schools of giant fish dart through waters teeming with predators. Other dinosaurs and crocodiliforms watch from the edges, wary of this shadow gliding silently beneath the surface. When Spinosaurus strikes, it is swift and precise, a combination of anatomy, instinct, and evolutionary design. Its success in this habitat was absolute. It could dominate rivers while other giants prowled the plains, untouched by competition in this niche. The implications of Spinosaurus extend beyond the creature itself. Its adaptations force scientists to reconsider the evolutionary possibilities of theropods. The existence of a semi-aquatic predator this large demonstrates that dinosaurs were not limited to land, but could innovate in response to environmental opportunities. The river hunter challenges assumptions, showing that evolution is not linear, predictable, or constrained by our expectations. Yet even with modern reconstructions, questions remain. The exact function of the sail, the full range of locomotion on land, the social behavior and precise hunting methods are all matters of ongoing research. Each new fossil adds a layer of understanding, yet simultaneously raises more questions. Spinosaurus is a reminder that science is a journey of discovery, a process of constantly revising knowledge in the light of new evidence. This is the twist that keeps us watching. Spinosaurus was not merely a larger predator than we imagined. It was a creature that fundamentally challenged our understanding of dinosaur ecology, evolution, and anatomy. Its discovery forces us to re-examine other predators, to question assumptions, and to recognize the vastness of evolutionary possibility. It is not just another dinosaur, it is a paradigm shift, a living illustration of how life adapts in extraordinary ways. And as we piece this puzzle together, from Stromer's initial discovery to Ibrahim's excavations, from fossil analysis to biomechanical modeling, we begin to understand not only how Spinosaurus lived, but why it matters. It matters because it changes our perception of dinosaurs, ecosystems, and evolutionary innovation. It matters because it reminds us that the past holds surprises beyond imagination. And it matters because the river hunter, once a shadow in a desert, has returned to illuminate the astonishing creativity of life on Earth. Tonight, we will continue to follow its trail, from fossilized fragments to reconstructed skeletons, from dry riverbeds to computer simulations, revealing a predator that rewrote the rules of evolution. Stay with me, because the revelations yet to come will forever change what you thought you knew about the age of dinosaurs. The world of Spinosaurus did not endure. Rivers that once teemed with life gradually receded, the lush floodplains dried, and the creatures that had dominated these waters faced the inexorable forces of time and change. As continents shifted and climates transformed, the ecosystems that nurtured the river hunter collapsed. Spinosaurus, along with countless other species of the Cretaceous, vanished from the earth, leaving only bones to whisper the story of their reign. But extinction is not erasure. Fossils, pressed into stone over millions of years, preserved the evidence of life, evolution, and adaptation. Vertebrae, jaws, and claws remained as silent witnesses, waiting for human curiosity to uncover their secrets. In the chem beds of Morocco and the sands of Egypt, paleontologists would one day unearth these remnants, revealing the extraordinary anatomy and behavior of a predator that once ruled the rivers. The disappearance of Spinosaurus coincided with broader ecological upheaval. The late Cretaceous saw dramatic changes, fluctuating sea levels, volcanic activity, and shifting climates reshaping habitats. Rivers dried or changed course, forests retreated, and the delicate balance that allowed a semi-aquatic giant to thrive was disrupted. In the wake of these changes, other predators took to the land and plains, but the specialized niche of the river hunter remained vacant, an evolutionary experiment lost to history. But the legacy of Spinosaurus is far from gone. Its fossils have rewritten textbooks, challenged assumptions, and inspired generations of scientists. Before Stromer's drawings and Ibrahim's excavations, paleontologists assumed that all giant theropods were land-bound predators, designed to stalk prey across plains and forests. Spinosaurus demonstrated that evolution is inventive, capable of producing forms that defy conventional expectations, adapting in ways that would have seemed impossible to its contemporaries and even to modern observers. Consider the implications. If a dinosaur this large could evolve adaptations for a semi-aquatic lifestyle, what does that suggest about the diversity of Cretaceous ecosystems? What does it tell us about ecological niches, predator-prey relations, and the limits of adaptation? Every vertebra and fossil fragment recovered from the sands provides answers, but also invites new questions. Science, like the rivers of Spinosaurus's world, is never still.
Its legacy extends beyond paleontology into popular culture, where Spinosaurus has captured imaginations in films, books, and exhibitions worldwide. Yet its true significance lies not in spectacle, but in revelation. This was a predator that rewrote our understanding of evolution, a giant that challenged preconceptions about what dinosaurs could be. It serves as a reminder that the past is full of surprises, that our assumptions about life are provisional, and that curiosity is the key to uncovering truths hidden for millions of years. Even today, debates continue. Was Spinosaurus fully aquatic or semi-aquatic? How did it reproduce? Did it interact socially, or was it solitary, like most modern large predators? These questions are not minor details. They shape our understanding of evolutionary possibilities. Each discovery, every fossil unearthed, every bone reconstructed, reshapes the narrative, emphasizing the complexity and wonder of life during the Cretaceous. And as we reconstruct the river hunter, we recognize its broader lesson. Evolution is not a straight line. It is experimental, creative, and adaptive, producing forms that can astonish and confound. Spinosaurus reminds us that even giants, creatures seemingly locked into specific ecological roles, could innovate in extraordinary ways. Its sail, tail, and limbs are more than anatomy. They are evidence of evolutionary ingenuity, markers of a predator that was both specialized and revolutionary. The modern rediscovery of Spinosaurus has not only rewritten the history of one predator, but has forced a re-evaluation of entire ecosystems and evolutionary strategies. When Nizar Ibrahim and his team published their findings in 2014, the world of paleontology was shaken. Spinosaurus was no longer just a large, bizarre dinosaur known from Stromer's century-old drawings. It was real, semi-aquatic, and uniquely adapted to a life straddling land and water. Its very existence challenged long-held assumptions that large theropods were solely land-based hunters, that rivers could not support apex predators of such size, and that evolutionary constraints prevented such radical adaptations. The river hunter became a symbol of scientific possibility, illustrating that the fossil record, while incomplete, could still surprise and revolutionize understanding. But the discovery also illuminated a larger truth. Science is a process of constant revision. For decades, researchers had pieced together clues from fragmentary remains, sometimes drawing inaccurate conclusions. Some reconstructions assumed Spinosaurus walked bipedally, like T-Rex. Others imagined it as a land-bound predator. Only with the full skeleton and biomechanical studies did the semi-aquatic reality emerge. This is the scientific twist, the lesson embedded in the bones that continues to captivate researchers and viewers alike. Reconstructing Spinosaurus required integrating multiple fields: anatomy, sedimentology, biomechanics, and paleoecology. Its elongated neural spines, powerful forelimbs, and crocodile-like tail each told a story, but only together did they reveal the full narrative of a river-bound predator. Modern computer simulations modeled its swimming abilities, demonstrating that the flattened tail could generate significant propulsion, while the body's center of mass supported balance both in water and on land. Every detail, from tooth shape to limb proportion, confirmed what Stromer had intuited a century earlier. This was a creature adapted to an extraordinary lifestyle. The implications extend far beyond a single species. Spinosaurus prompts reconsideration of predator-prey dynamics, niche specialization, and the possibilities of convergent evolution. Its semi-aquatic adaptations resemble those of modern crocodilians, yet it is a theropod, an entirely different lineage. This convergence illustrates how evolution repeatedly finds similar solutions to environmental challenges, yet in Spinosaurus, the scale is unprecedented. Imagine for a moment the rivers of the mid-Cretaceous, waterways flanked by floodplains and forests alive with fish, crocodiliforms, and smaller dinosaurs. Here, Spinosaurus reigns supreme. Other predators dominate land, but none claim these waters. Each ambush, each strike, demonstrates evolutionary precision. The river hunter's anatomy allows it to exploit resources unavailable to its competitors, reinforcing the lesson that life is adaptable and ecological niches are limited only by innovation. Beyond biology, Spinosaurus's rediscovery is a story of perseverance and collaboration. From Stromer's initial sketches to Ibrahim's Moroccan excavations, from local fossil hunters to international research teams, the narrative spans continents and generations. It is a testament to human curiosity and dedication, showing that science is not just about discovery, but about persistence in the face of loss, destruction, and skepticism. The river hunter also leaves a profound philosophical legacy. It reminds us that our assumptions about life are provisional, that even the most massive predators can evolve in ways we never imagined. Its life challenges us to question our understanding of ecosystems, adaptation, and the boundaries of possibility. In Spinosaurus, we see nature's creativity, unrestrained and extraordinary. As we reconstruct the creature in museums and simulations, exhibit its massive skeletons, and model its behavior, we come to understand why this predator matters. It represents the intersection of history, science, and imagination. Its rediscovery emphasizes the importance of fieldwork, careful documentation, and interdisciplinary research. Each fossil, each vertebra, each tooth carries a story waiting to be interpreted, a narrative that reshapes our understanding of the natural world. Even as debates continue, the impact is undeniable. Questions about locomotion, diet, and reproduction remain, yet each discovery brings clarity. Spinosaurus continues to inspire new research, prompting scientists to look for other semi-aquatic adaptations in theropods and reevaluate assumptions about other extinct species. The river hunter is more than a curiosity. It is a catalyst for knowledge, driving inquiry across paleontology, biomechanics, and evolutionary biology. And so we arrive at the lesson embedded in millions of years of stone. Spinosaurus is not simply a predator, it is a paradigm shift. Its existence forces us to reconsider what we know about dinosaurs, ecology, and evolution itself. From the riverbanks of ancient Africa to the laboratories of modern science, the river hunter teaches patience, perseverance, and the power of observation. Tonight, we have traced its story from the first fragment unearthed by Ernst Stromer through the destruction of Munich's museum to the Moroccan sands where Nizar Ibrahim's team breathed life back into a forgotten predator. We have explored its anatomy, behavior, and the incredible adaptations that allowed it to dominate rivers while others ruled the plains. We have seen how science, curiosity, and imagination combined to reveal truths hidden for millions of years. And yet, the river hunter's story is not finished. With every fossil still buried, every riverbed unearthed, every question answered, new mysteries arise. This is the nature of discovery, a reminder that knowledge is a journey, that curiosity never rests, and that even the most iconic predators of the past can continue to surprise us. So, as the sun sets over the reconstructed rivers of North Africa, let us remember Spinosaurus not just as a creature of flesh and bone, but as a symbol of what is possible. A predator that swam, hunted, and thrived in a world unlike any other. A predator that challenged assumptions and forced science to evolve. And most importantly, a predator that reminds us that the past is never truly gone, that the river hunter waits in the sands, calling to those willing to uncover its secrets.
For those who have followed this journey, the story is clear. Evolution is extraordinary, adaptation is profound, and the past holds lessons that echo into the present. Spinosaurus, the river hunter, is more than a dinosaur. It is a reminder that life is inventive, unpredictable, and astonishing. And now, as we leave the rivers behind, we carry with us a truth revealed only through patience, curiosity, and the courage to see the world as it truly was, that even the largest predators can redefine the rules, and that the river hunter, lost and found, will forever change the way we see the age of dinosaurs.